All right, in this lesson, in section 10.4, your final lesson, we are going to discuss how to transform data so that we have linear data to look at. In statistics, we are not going to look at any type of data and make predictions about any data that is not linear. There are two main equations that we are going to look at. One is going to be called a power function, and the other one is going to be an exponential function. We are going to take the power and the exponential functions and transform the data in order to make it linear so that we can make predictions about future response variables. All right, so previously in this chapter, we learned how to analyze relationships between two quantitative variables that showed a linear pattern. In statistics, we are only dealing with linear patterns. If the pattern is nonlinear, then in statistics, we don't have a way to analyze the data. So if when we graph the data, we notice that there's a curved relationship, we have to develop some sort of new technique in order to find an appropriate linear model. So what this section does is this section talks about how we can transform the data. So we will take a data that is curved and make it straight we make it straight into a linear pattern. So it takes a nonlinear pattern and makes it straight. So once the data has been transformed and we have a linear pattern, we can use our least squares regression line to create a linear model to make predictions about the response variable. Now, if the conditions for regression inference are met, we can estimate or test a claim about the slope of the population or the true regression line using our transformed data. And the key here is that we're only going to use the linear data. All right, so let's just take a minute and review what linear data looks like. Linear data is always in the form y equals a plus bx in statistics or y equals mx plus b. Okay, either way is totally fine, but in statistics, you will most likely see the y-intercept first and then the slope and then x, okay? So the word linearization is the process of transforming data. In our case, it's going to most likely be curved or nonlinear data into linear data. It's pretty cool. We're going to use the properties of logarithms to transform our nonlinear data into linear data. Now, these are just a few reminders of what the properties of logs are. This is not necessarily something that you will see on the AP exam, but I just wanted to give you some reasons as to why this works, okay? So just as a reminder, exponents and logs are inverses of each other. So remember, if we have a log function, so log b to the x is equal to y, we can always rewrite it as an exponent by using the property. So you take the base of the log, that becomes the base of the exponent, and then the number after the equal sign becomes your exponent equals whatever is next to your log value. Okay, so they're inverses of each other. And here's just some refreshers of your properties of logs. So remember, if you have the log of a times b, if you're multiplying it, you can separate it and make it the log of a plus the log of b. If you're dividing it, you can make it the log of a minus the log of b. Whatever is in the denominator is what's after the subtraction sign. If we have an exponent on what's next to the log, we can pop that out as a coefficient. And remember, if you have an exponent, you can always rewrite it as a log. So in this case here, I kind of have a circle method that I remember this. I would write it as log, whatever is the base of the exponent is the base of your log, okay? And then you're going to go across the equal sign, that's what goes next to the log, equals, go across the equal sign again, x, okay? Now remember, log base 10, you don't have to write the 10 there, it's understood, so it's just log y equals x. All right, so here's just a couple examples of using the properties of logs in order to simplify the following expressions. So log of 2 of x, since this was multiplied, what I can do is I can separate it by making it separating these two bases right here. The log of 2, since it's multiplied, plus the log of x, okay? This should be log 2 over x, Since they're divided, whatever is on top is the addition. So this is the log of 2 that's on top. Since the x is in the denominator, so 2 over x, we're going to subtract what's in the denominator. We have log 2 to the x. Remember, if you have an exponent, then you can pop that out front as a coefficient. So that becomes x log of 2.